Hello again, Dr. Lee Newton back again for part 3 of my 4-part video series about indoor air quality. This segment is about practical indoor air considerations if you are in decision-making mode, for example, or if you're going to do a remodel or a new build, or if you simply want to know what things you need to be thinking about with your existing system. So, what is the most common thermal comfort system, heating and cooling system, installed in homes, apartments, offices, buildings in the United States? You probably guessed forced air heating and cooling, and you would be absolutely correct. Second question, what is generally the worst system for thermal comfort with regard to the 5 principles of thermal comfort? So in video number 1, I talked about the 5 principles of indoor comfort are temperature of the air, humidity of the air, mean radiant temperature, drafts, and air purity. Okay, so mean radiant temperature, slightly outside the scope of this video series, but let's talk about it this way. If the air in your room is 70 degrees and it's wintertime, and you stand close to a window and you say, wow, I'm cold, and then you look at the thermostat and it's reading 70 degrees and you've set it at 70 degrees, so it's not heating, but you say, wow, I'm cold, you are radiating more heat to the window than is being radiated back at you. There is no equilibrium established there and you're losing heat. That's why you feel cold. That's what mean radiant temperature means, and that's something that when we design structures we have to think about. If we have too many windows, you have the opposite effect in the summer. Wow, I feel hot, thermostat's at 70. Drafts are self-explanatory. Air purity is my air being filtered. So you take those 5 principles of comfort, which heating and cooling system is the worst at controlling them, and the answer is forced air heating and cooling. You're going to say, what the heck? Why? It's everywhere. Well, it's everywhere because it's relatively cheap and easy to put in, install, easy to work on, easy to fix if it fails in the future. But the answer to the question why is that it's only controlling air temperature. Now, I also referenced in a previous video that, yeah, when you're cooling, it's removing humidity from the air. That is correct. So you're controlling air temperature, you're influencing humidity content, but you're not controlling humidity. You don't have a humidistat. You don't say, keep cooling until the air temperature is 70 and the indoor relative humidity reaches 45%. The systems like that may exist, but they're not practical. They're not used. They're not installed in homes and apartments and office buildings. Final question, is it ever okay? That's probably a stupid question on my part. Well, obviously it's okay. It meets building codes, mechanical codes, whatnot, all across the United States, probably in other countries all across the world. I would say it's not okay if you don't understand what it's doing versus what it's not doing. You know, you might think, well, yeah, but I can run my fan all the time and I am purifying my air 24/7 because it's running through the filter. Okay, that's fine, but you're still not influencing the other factors of the principles of comfort. Let's look at, next slide here, typical forced air setup in a home or office. Okay, so this is a home or an office. It's a structure that has no doors or windows, so it won't meet fire code. Sorry about that. Simple sketch. So you have a mechanical room in your home or office, and I use the colors blue and red to denote supply and return. I probably shouldn't have done that because red typically means warm, heating, and blue typically means cold for cooling. So forget about that. They're supply and return. Let's say the red's the supply. Okay, so all forced air is blowing and sucking. You're blowing out conditioned air through registers, through diffusers, but you're also sucking back room air or stale air to be recycled through the filter in your furnace and to be reconditioned and sent back out again. So again, you're blowing and sucking, that's all you're doing. You're also heating and filtering, or cooling and filtering. Okay, so your mechanical room, you have ductwork. The red is the supply. It goes out to the rooms. It's got little diffusers, little registers in the ceiling or on the floor or what have you. And the blue are the return registers. So everything's fine and dandy. You're happy. You've got one furnace that does your whole home or your entire office, and everybody's happy. Everybody that works there is comfortable. Probably not, because there are drafts and cold spots. That's a topic of a different video. But let's say you do a modification to this. Now let's say it's an office. You do a modification. You say, gee, I don't need all this space because of whatever. I'm going to build a wall and section off one end of it, and I'm going to rent that to another professional, another business, or what have you. So you have the bold lines that outline the area that you've sectioned off to rent. Now somebody else's business there, or maybe you have an old house and you build a wall and you have an efficiency apartment there, and then you have a 2-bedroom apartment with the rest of it because you find that you get more rent that way. So you modify it by building walls. Now this produces the following concerns, and these are significant. Number one, fire. Okay, fire from lack of fire blocking. So if a fire starts in one side of those walls and you haven't built your walls and you haven't done installed fire blocking all the way up to the top to the roof deck, fire could easily spread. So tenant A could burn down tenant B, not just tenant A's suite. Overlap of utilities. Let's say you have an electrical circuit that has receptacles or plugs on both sides of those walls, and somebody plugs in something that draws a lot of current and they overload the circuit, they start a fire. Well, that fire is instantly spreading. Even if you've got it fire blocked, that fire is going to spread because of the electrical wiring that is on each side of that demarcation wall. Gas service. Okay, let's say you have let's say you put in a little combustion heater, little furnace in the smaller suite, and you have a fire there. Then that's, if you overlap the gas utilities, you have similar hazards. Number two, mixing of conditioned air in terms of thermal comfort, hot, cold. We're going to do a deeper dive on the next slide on that one, but that's a concern. Number three, you have mixing of the indoor air in general if the walls aren't sealed all the way up. In other words, if that smaller suite is not completely compartmentalized, you have recirculated air that can go above, the drop ceiling, for example, or through the walls because your electrical outlets aren't completely airtight, and you can mix indoor air in general. And tenant A and tenant B might not have the same cleanliness habits, okay, or business owner A, business owner B, they may not have the same type of business, and you might have fumes and contaminants. That's item number four. If you have a beauty salon, you have fumes, VOCs, that simply go from suite A to suite B. Let's say you had a pot shop, same idea. Use your imagination. Not good. Next slide, I'm going to do a deeper dive on number two. So we have the mixing of conditioned air. So let's say that you have no other concerns, everything else is taken care of, and you're compartmentalized, but you still have one furnace or air conditioner and one thermostat controlling. Well, what is the likelihood that tenant A, tenant B, business owner A, business owner B are going to be mutually and completely happy and satisfied with the temperature? And that, I would say, approaches zero. So you're going to have one thermostat. Who gets the thermostat? On what side of that partition wall does it go? Okay, that's one question. Now, what if you had two thermostats? You still had one zone, but you had two thermostats. That was probably a stupid item to put in there because you really can't have that. They would fight each other and you'd burn up your system. But I guess I put it in there to show that that's not a possibility. Item C, if you had two zones, so if you took the existing ductwork and you put in electronically controlled dampers on the diffusers and the returns, so that when tenant A is blowing and sucking to provide conditioned air, the registers are all blocked off in tenant B, and vice versa. Okay, possible, but it's not done. I'm just here to tell you because it's not practical and it's very, very expensive. So if you simply blocked off the ductwork so none of the air flowed across that dividing wall, put fire block in there and whatnot, and then you compartmentalize a smaller suite with its own system, that's the way you want to do it. Everybody's happy. It's not done because it costs money. It's an unnecessary expense in many people's minds, but it's the only way to do it right, in my opinion. This equally, probably more crude sketch is a sketch of the heating and cooling zones in my office building. I have 3 zones, 3 furnaces, 3 air conditioners, and at first glance you might say, well, gee, all the supply and returns from zone 1 are completely separate from zone 2 and zone 3, and so on and so forth. You might think, wow, there's no way that air can be mixing because zone 2 doesn't supply conditioned air to zone 1 or zone 3, and so forth and so on. But let's take it a step further and go up on the crudeness level of my sketch. So I've taken black Sharpie and drawn in a hallway, a door, different rooms, and so forth. Now you see that, oh, okay, even though zone 2 only serves zone 2, zone 1 only serves zone 1, zone 3 only serves zone 3, I can open the door from zone 2, walk down the hall, that mixes the air. So air gets mixed anyway. You don't have this force field of the different zones and the air doesn't mix. You have mixing of air in multi-zone HVAC. I bring these items up because I feel that many business owners, landlords, homeowners, residents they always think it's somebody else's responsibility to provide acceptable IAQ for their family, themselves, their customers, their patients, and so forth. And we all need, in my opinion, to take a big responsibility for it. We all need to be aware of the air quality in our homes and our offices. Many business owners have no idea when their filters were changed. They only call the HVAC company when they have a problem. And then the furnace filter looks like my example in the previous video. You know, in the commercial setting, you could be breathing air you don't want to breathe from the office that you're in, if you have multiple zones, for example, or from the other office next door if you haven't compartmentalized the structure. A little bit of greenbuildinglawupdate.com website. We should eliminate the use of recirculated air. Now, going back to my office example, it's only recirculated in my office. I don't have another business renting. I have 2 businesses in my building. They're completely compartmentalized. They have their own supply and return. There is 0 mixing of conditioned air. I have 3 zones just because we have a bigger facility here and you can't provide heating and cooling effectively across 5,000 square feet with 1 zone. Okay, so what greenbuildinglawupdate.com is saying is that we should eliminate the use of recirculated air. What they're referring to is the cobble job that I'm talking about earlier, or in older high-rise apartment buildings, all that air that gets recirculated and forced out in different suites and so on. My point is, my editorial point, it might be possible to do that in new construction, but very difficult, meaning expensive and hard work on existing construction. New York Times had a piece from Dr. Joseph Allen, director of the Healthy Building Program at Harvard, in his article, and there will be a link in the reference section, that he told the story of 1974 in elementary school in New York. A girl had measles. Okay, so she didn't know it at the time because there's an incubation period. 97% of her classmates were vaccinated against measles. I don't know how many classmates she had. It wasn't apparent from the article. However, 28 students across 14 different classrooms contracted measles. And how is that possible? Ventilation system, sucking and blowing, sucking and blowing, sucking in the contaminated air, blowing it out elsewhere. Now, I'm not trying to make you scared of your child's school. They could very well have radiant heat and no forced air. I don't know. But I say this to kind of get your mind going on this is a real problem, and it's probably going to be a more problem depending on if we have a big second wave of the coronavirus or if it fizzles out quickly. Some closing thoughts. Mudari 10 years ago felt that the increasing stringency of energy codes were focusing on energy only, sometimes at the expense of IEQ. In other words, all the focus was on saving fossil fuel consumption and saving energy consumption in the individual home, not thinking too much about IEQ. Joe Stieberich with Building Science Corporation had these thoughts in 2006. In 2006, 14 years ago, he was advocating for the compartmentalization of multifamily residential structures, citing benefits in the smoke and fire areas. Energy efficiency is greater, more comfortable thermally, and way better indoor air quality. So this was a thought that I spoke about in this video, but it was originally, and people probably talked about it before him, but he was advocating for this 14 years ago, before the coronavirus was a thing, before we're talking about IAQ. So that is something to think about. That will bring us to the conclusion of part three segment, video of air quality. And I, as always, welcome your questions. Please email me at lee@ceassets.com. You can also check out the practice website, newtoneyecarecenter.com, as well as my own personal website, drleenewton.com. That will go live July 2020. Thanks very much for watching. Hope to see you again soon.